but the other must be a polygon. See, the most important thing is you in these two data set, one of them should always be a polygon. You have to remember that you cannot apply a overlay operation on point to point or a line to line. You should have at least one must be a polygon data, polygon set. So that is the most important thing. So here you can see that the moment you intersect, the common areas has been delineated, and the good thing is you will have attribute from both the data. So if you see, you have the attribute of input data 1 and you have the attribute column of input data 2. So both the things you can get from the intersection. Similarly, if you see this, now here also now here both are having the same georeference, but their spatial extents are different. But the most important thing is there are certain overlap. So you can see that map extent B and map extent A automatically they intersect, but they have the whatever the area which is common, that is only taken into consideration. And we also take the whatever the heterogeneity available in both the polygons has been taken into consideration. And not only spatially, but also we are taking all the attribute of input 1 as well as input B. So both the things have been taken. So it is not necessary that both the extents should be same. There should be some overlap with the same projection system. Then you can easily run a intersect operation. Then you have a clip operation. Now in this clip operation, what we do, it is like a cookie cutter. You generate only this particular shape will be taken out, but the internal polygons will not be taken into consideration. So it restricts the spatial extent to the outer boundary of the second layer, and no other polygons from the second layer plays a role. So only the outer boundary plays a role, and here it will cut, and it will the attributes from this as well as the spatial will be taken from the clip input. Then we have another one that is called as overwrite operator. Overwrite is just to place this particular the overwrite operator onto this, and the moment you put this, so you will have, it will be just like a stamping. You stamp this, or you put some any image or something like that, or any polygon. Here you can put the polygon, and the attributes will also be there as well as your entire. So spatially also you are getting the entire information. So this as well as this will be the part of the overwrite. Then we have also a function. We have also another function that is called as a neighborhood function. This neighborhood function basically is like a proximity analysis. Will find out the characteristics of the vicinity of a location. So to perform neighborhood analysis, we must state which target locations are of interest to us and what is their spatial extent, and define how to determine the neighborhood for each target, and define which characteristics must be computed for each neighborhood. So here basically we generally talk about the proximity, like the equidistant. Like if we select a point and we say that I want the area with 2 kilometers radius, so you can see that there is a equidistant area of 2 kilometers along the point. Similarly, it can be along different number of points. You can combine these buffers, and also you can have different neighborhood operation like allocation, which basically defines the resource capacity of a particular area. So you can characteristics could be how many people live in the area, what is their average household income, or are there any high risk industry located in the neighborhood. So these type of things can be done by making use of neighborhood functions. So they are also called as a proximity computation, that is buffer analysis. It is called as a buffer generation. And then there is another thing which is called as a Thyssen polygon, which is also called as a Euclidean allocation. We will discuss in detail about this. And then there are certain more neighborhood operations like spread computation or seek computation, which are common in raster data. So we will discuss about buffer and Thyssen polygon. So like buffer, you can apply n number of you can apply a single buffer, or you can even apply a multiple buffer along the different lines. So you can see that you have a 1 kilometer buffer, 500 meter buffer. You can also have multiple buffers between 0 to 100, or you can have any unitary number between 100 to 200, or you can even have between 200 to 300. So you can have multiple buffers in a particular. So in this line you have 100, then 200, then you have 300. So you can have a multiple buffers along the network. Then there is a Thyssen polygon. Now this particular Thyssen polygon is mostly being used in weather applications like rainfall data. Whenever you want to generate a Thyssen polygon, like whenever you want to do the interpolation for the rainfall data, you can use a Thyssen polygon. So basically you divide your entire, if you see this particular thing, there are certain points which are having a point value like rainfall value with different numbers. So what we do, we generally first partition the plane into a polygon, so that each polygon contains location that are closest to the polygon's midpoint, then to any other midpoint. So here you can see that here you are basically first you are making a tin model, and then you use like Delaunay triangulation to calculate the basic different type of polygon. Now if you see this, how I will do, suppose I want to generate a Thyssen polygon for this particular point or this particular weather station where the different rainfall data is there. So what I'll do, I'll connect to these points, I'll draw a bisector on all these points, and what I'll do, I'll draw a perpendicular to all the bisectors and join these all the perpendiculars. So the moment I join, I will get a shape something like this. So you can see that by making use of Delaunay triangulation, you can easily generate a polygon with equidistant. So you can see that like the rainfall, the moment any point, if you want to get the rainfall intensity in any of these area, the value will be almost same to this particular point. Similarly, you have certain same number for this and same number like inside this, the number will be same to this particular point. So this is being used in rainfall. Why? Because if you see rainfall it changes point to place, and like especially if you talk about a mountain ecosystem, you may have a different orography, and because